Hi everyone, today I will explain how thermocouple converts the engineering quantity into electrical signal. Thermocouple comprises of two dissimilar metals A and B. They are joined together to form two junctions P and Q, which are maintained at a temperature of T1 and T2. Remember that thermocouple cannot be formed if there are no two junctions. Since the two junctions are maintained at different temperature, the Peltier EMF is generated within the circuit, and it is a function of the temperature of the if the temperature of both the junctions is same, T1 and T2, equal and opposite EMF will be generated at both junctions, and the net current flowing through the junction is zero. The total EMF flowing through this circuit depends on the metals used within the circuit as well as the temperature of the two junctions. The total EMF or the current flowing through the circuit can be measured easily by using suitable device. Measurement of the temperature of the body. One junction of the thermocouple is connected to the body whose temperature is measured. This junction is known as the hot junction or the measuring junction. The other junction is connected to the body whose temperature is known. This junction is the cold junction or the reference junction. The devices for measuring the current or EMF is connected within the circuit of the thermocouple. It means here it measures the amount of EMF flowing through the circuit due to the junction of the two dissimilar metals maintained at different temperatures T1 and T2. Two devices used commonly are the ordinary galvanometer and voltage balancing potentiometer. Now, the temperature of the reference junction is already known, while the temperature of the measuring junction is unknown. The output obtained from the thermocouple circuit is calibrated directly against the unknown temperature. The voltage or current output obtained from the thermocouple circuit gives the value of the unknown temperature directly. I think that's all from me. Thank you.
Assalamualaikum and a very good day to everyone. In this video, we are going to explain about thermocouple sensor. Thermocouple sensor is actually one of the device for measuring temperature. It is consists of two dissimilar metals joined at one end called the measurement junction or hot junction. The other end, at where the metals are not joined, is connected to the signal conditioning circuitry traces, typically made of copper. The junction between the thermocouple's metals and the copper traces is called the reference junction, or known as cold junction. There are four most common types of thermocouples, which are type J, K, E, and T. A thermocouple is created whenever two dissimilar metals touch and the contact point produces a small open circuit voltage as function of time. This thermoelectric voltage is known as Seebeck effect. The voltage is non-linear with respect to temperature. However, for small changes in temperature, the voltage is approximately linear. This is the delta voltage. Delta V is changes in voltage, approximately linear, with the S is the Seebeck coefficient, and delta T is changes in temperature. The Seebeck coefficient is varies with changes in temperature, however, causing the output voltage of thermocouples to be nonlinear over their operating ranges. The voltage produced at the reference junction depends on the temperature of both measurement junction and the reference junction. Since the thermocouples is a differential device rather than an absolute temperature measurement device, the reference junction temperature must be known to get an absolute temperature reading. This process is known as reference junction compensation.
Okay everyone, today I will explain the sensitivity of the thermocouple. Here, as you can see, there are several types of the common type of the thermocouple available, which is B, E, J, K, and R, S, and T. Each of type of the thermocouple have a sensitivity characteristic and optimal temperature measurement range. This graph shows that the thermocouple voltage produced by of each as a function of the temperature. Here we assume that the cold junction at 0 degree C. As you can see, most of the thermocouple become less sensitive. That is, the slope of the graph is less at lower temperature. Okay, for each of the thermocouple types, this is summarize of their composition for the plus and minus leads, and then sensitivity and approximate useful temperature range. So that is for the type B is 5. The sensitivity is 5 to 10 microvolt per degree C. So this is the last is EJK, which is 40 to 80, 50 to 60, 28 to 42, 24 to 38 microvolt per degree C, 8 to 14 degree C, 8 to 12 microvolt per degree C, 17 to 58 microvolt per degree C. Okay, that's all for me. Okay, thank you. Thank you very much.
Okay, Assalamualaikum and a very good day to all of you that watch this video. Okay, I'm here to present about, to explain about what the operation of thermocouple. Okay, before I explain about the operation of thermocouple, explain what is thermocouple. Okay, thermocouple is a sensor that measure the temperature. Okay, di sini saya akan terangkan. Okay, di sini adalah wire yang cantum dan ini adalah dua jenis unsur wire yang berlainan, iaitu kromen dengan alumen. Adalah positif, negatif. Ini contoh untuk suhu 300. Okay, ini contoh dia, jenis type K. Okay, ini contohnya untuk suhu 300 dikenakan pada hujung yang bercantum. Okay, ini itu bila dikenakan kat sini akan berlaku tekanan. Tekanan ni akan mengalihkan daya lah. Tekanan akan mengalihkan voltage yang dinamakan EMF, voltage of electromagnetic force. Okay, proses ni yang saya terangkan ni dinamakan dengan nama seatbelt. Okey, dekat dalam thermolet ni kita ada macam ni lukisan dia. Okey, di sini kalau dekat dalam thermolet tu dia macam ni. Ni adalah kawasan yang dua jenis unsur logam wire ni dicantumkan. Okay, kat sini lah akan dikenakan suhu. Perbezaan suhu tu akan dijadikan tekanan. Tekanan ini akan berlaku dan menghasilkan EMF tu. Okay, dan akan masuk kepada voltmeter lah. Voltmeter ni akan ukur berapa suhu yang ada dekat kawasan sekitar ni lah. Ataupun kita boleh menunjukkan untuk suhu air. Macam ni ada air bekas yang telah dipanaskan. Okey, kat situ thermocouple dimasukkan. Okey, kat sini kita boleh tengok air ni dia panaskan. Tak tahu berapa darjah Celsius, mungkin dalam 300 ataupun ke atas kan. Okey, jadi kita nak detect berapa suhu dia, kita masukkan termokapel ni. Termokapel ni, okey, kawasan kat sini ni yang bercantum ni akan kenakan daya dah, perbezaan suhu, dan akan menghasilkan EMF, electromagnet force, ataupun dia menamakan termoelektrik. Okey, lepas tu akan dimasukkan, akan mengalir pada wayar yang tak bersambung ni, dan connect disambungkan dengan DAQ. DAQ ni adalah di mana nilai analog dikonvertkan kepada nilai digital dan dimasukkan ke dalam, ditransfer dalam laptop. Dan di laptop ni lah akan menghasilkan, akan keluarlah nilai-nilai berapa suhu dalam ni. Okey, itulah, saya harap korang faham lah apa yang saya terangkan tentang operasi termokapel. Okay, that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Rahim bin Sakari, and today I would like to present about the application of thermocouple sensors. So, where is thermocouple sensor is used in our industry and our economy system? Actually, industrial system with the temperature measurement for kilns, second gas turbine exhaust, and the third is diesel engines. The thermocouple sensor are used widely in these three types of industrial engineering system. So, besides that, plastic industry also prefer cost-effective thermocouple without magnesium, spring adjustable and bonnet cap style for quick install. Besides that, other industry do like thermocouple assembly consisting of thermal elements swept in hard packed magnesium oxide, so that they can form and bend into radius twice the size of the element. So we go to the type of thermocouple. Basically, thermocouple have four types of sensors. There is J, T, K, and E. They have its own special skills and characteristics, with its resistivity, temperature, and resistivity. So, as a mechanical future engineer, how do we choose the thermocouple type? This is the characteristic that we should focus: temperature range, chemical resistance of the thermocouples, corrosion and vibration resistant, installation requirement. And this is the last two types of thermocouple sensors: beaded wires and thermocouple port. Beaded wire is simplest form of thermocouple. It consists of two pieces of thermocouple wire joined together with welded bead, and it cannot use with liquid because it can corrode the aluminium of the thermocouple sensors. And the thermocouple port has wire inside a metallic tube. It has three types: grounded, ungrounded, and at post thermocouple. Thank you for listening. That's all from me.